Lesson 6.6 is on solving trigonometric equations. So we're going to give you a bit of an introduction to how to solve a trigonometric equation here in this online lesson, and then we'll pick up and do several more equations when we get together in class. So let's take a look at this equation. We're being asked to solve 2 sine x minus 1 equals 0. Now, the way to start in this case, I hope, is going to seem pretty normal, where we need to get the sine of x isolated. In order to be able to solve for what sine of x, what the x should be, we need to get sine of x equal to some number. And so in this case, we would start by adding the 1 to both sides. So we would get 2 sine of x equal to 1. And then we would divide both sides by 2 to end up with the sine of x equal to 1/2. Now, based on what we talked about last lesson, it seems like our next step would be to take the inverse sine of both sides. And indeed, that is our next step, but we need to think about this a little bit differently than last lesson. So here we have our sine and our our sine and our inverse sine canceling each other out and leaving us with an x. And here we're left with inverse sine of 1/2. Now, based on our last lesson, if I were to go to my calculator right now and find the inverse sine of 1/2, the answer I would get would be the decimal equivalent of pi over 6. Okay, now that comes from the fact that the calculator can only deal with inverse sine as a function. So as a function, we only have the first and the fourth quadrant to choose from. Since we're taking the inverse sine of a positive 1/2, that means we want the angle measure that is in the first quadrant that's going to make that happen. And that angle measurement would be a pi over 6. So as a function, x would equal pi over 6. And in our calculator, that's the only answer we would get, because the calculator can only deal with functions. However, when we're talking about solving an equation, our focus is not on what is the one output number I get to make it a function. Our focus is on what are all of the possible values of x that I can use that are going to make this equation true. So if we look at this graphically, you can see here that we have the graph of y equals sine x, and then since we ended up with that being equal to 1/2, we also have here just the line of y equals 1/2. And every place we have an intersection point, that is a possible x value that would be a solution. And because my sine graph would continue to go both to the left and to the right, we would assume that we would continue to get points along the graph where the sine of x would equal 1/2. So when we're solving an equation, we actually have infinitely many solutions. Now, if we just look in the first period, the first rotation, that would be from here, 0, until here, 2 pi. And within that period, we can see that we have 2 solutions. One is at the pi over 6, which our calculator would have given us, but then the other is in the second quadrant at 5 pi over 6. Okay? So within one quadrant, or excuse me, within one period of my sine function, there are actually two different angle measures that would give me a 1/2 if I took sine of them. Okay? And so going back to what we talked about in a previous lesson, in order to represent all of these solutions as well, we would take the two solutions that we got in our first quadrant, and then we would add a 2n pi to both of them. Oops. Got my n there. 2n pi. There we go. Okay. These two expressions now represent every single possible solution that we could use to substitute in for x and get 1/2 as an answer. Now, that seems like a bit much. So we need to kind of find a happy medium. So as a function, we know that taking the inverse sine of 1/2 is only going to give us one answer. And the reason that we need to still keep that in mind is that if you type it into a calculator, your calculator will only give you one possible solution. But then we need to realize that as an equation, it's not just that one solution. We need all of the possible values that we can put in for x. And so there's going to be infinitely many solutions if we're really looking for everything. Not only do we get the pi over 6 from our calculator, we also get the 5 pi over 6 from one period, and then of course we have everything else from adding 2n pi. Well, that seems like a bit much, and that seems like it could be a bit complicated. So what we're going to be doing in class, and when we start going through our examples in class, we are going to just limit the solutions we're looking for to one period. So we are looking for the x values in the range from 0 to 2 pi that would make our equation true. And so in this case, what we would really be looking for is just the pi over 6 and the 5 pi over 6. Okay, so try to keep that in mind, let that kind of sink in a little bit, so that when we go through examples together in class, you'll understand why it's not just one answer, because we're not just dealing with a function, but we're not going to go totally crazy and try to get everything. We're just going to be looking for what are the values of x from 0 to 2 pi that would make my equation true. And with that, we'll be ready to start with examples in our next class, and we will see you then.